Hey everybody, welcome back. This is chapter 3.1, using graphs and tables to solve linear systems. All right, the objectives for today, we're going to solve systems of equations by using graphs and tables, and we're going to be able to classify systems of equations and determine the number of solutions. All right, so some vocabulary that you need to know. A system of equations is a set of two or more equations containing two or more variables. So all that's saying is y equals, say, 2x to the third plus 3, or y equals x cubed. This is simply a system of equations. We're going to be working with a special type of equations, linear systems. So that means our systems are going to contain only linear equations. So remember, linear equations have an x with an exponent of 1. So it would be like y equals x plus 3, or y equals 2x minus 4. Both of these are linear equations because has an exponent, an understood exponent of 1. All right, so that's what we're going to be working with today. Recall that a line is an infinite set of points. So if I have a graph here and I draw a line on it, every single one of these points are going to be true. And the solution of a system of equations is the set of all points that satisfy each equation. All right, so all of these points are going to satisfy one equation, and if I have another equation with a set of points, all of those points are true, and there's one point in particular that would be true for both equations. All right, so that's going to be our solution set. Let's just write it out a little more seriously. On the graph of the system of two equations, the solution is the set of points where the lines intersect. A point is a solution to a system of equations if the x and y values of the point satisfy both equations. Okay, so again, if we have a line and all these points and another line and all these points, the place where they intersect, there's going to be one point that will be true for both of them, and that will be our solution set. All right, so let's do some problems. The first ones are really pretty simple, so we're going to just use substitution to determine if the given ordered pair is an element of the solution set for the system of equations. So we're just going to substitute. Remember, this is our x and this is our y. So x is going to be 1 minus 3 times 3, our y, equals negative 8. 1 minus 9 is negative 8, which equals negative 8, so that ordered pair is true for that equation. Let's try the other one. 3 times 1, our x, plus 2 times 3, our y, is going to equal 9. 3 times 1 is 3, plus 6 is 9, and 9 equals 9, so it's true for both of them. Therefore, we can say because the point is a solution for both equations, it is a solution of the system. Let's try one more. All right, again, we're going to substitute. Remember, this is our x and this is our y, so we're going to say negative 4 plus 6 equals 4 times 1/2. All right, negative 4 plus 6 is 2, and 1/2 of 4 is also 2. So this is true, so this ordered pair is true for our first equation. Let's try our second equation. 2 times negative 4 plus 8 times 1/2, all right, equals 1. So 2 times negative 4 is negative 8, and 1/2 of 8 is 4. So negative 8 plus 4 is negative 4 equals 1. No, it does not. So that is not a solution. So we can say because the point is not a solution for both equations, it is not a solution of the system. So I'd like you to turn your video on pause for just a second and do the next problem on your own. Okay, this is an easy one to do, so we're just going to substitute in. Remember, this is x and this is y, so we're going to say 4 plus 2 times 3 equals 10. So 4 plus 6 is 10 equals 10, and that is true. So our first equation it works out with. Let's try the second one. 3 times 4 minus 3 equals 9. So that's 12 minus 3. 12 minus 3 is 9 equals 9. That is also true. So when both of them are true, we can say because the point is a solution for both equations, it is a solution of the system. Okay, try one more on your own. Put the video on pause and then come back. All right, this one again is really simple. X and Y, 6 times 5 minus 7 times 3 equals 1. 30 minus 21, that is actually 9, equals 1. No, it does not. So that is not, there's no point in even trying the next problem because we already know, because the point is not a solution for both equations. It is not a solution of the system. All right, so recall that you can use graphs or tables to find some of the solutions to a linear equation. You can do the same to find solutions to linear systems. So let's see what that means. All right, here's the first example. Use a graph and a table to solve the system. Check your answers. So on your homework, you're going to need to do a graph and a table. The first thing that we want to do when we're solving for a problem like this is we want to solve each equation for y. Okay, so when we do that, let's just solve each one for y. 2x minus 3y equals 3. So let's subtract 2x from both sides. So it leaves us with negative 3y equals negative 2x plus 3. Divide both sides by negative 3. And we end up with y equals positive 2/3 x plus 1. All right, and actually I forgot to do the negative there, so it's a negative 1. Okay, so here's our first equation. The second one's a lot easier. Y plus 2 equals x. So let's just subtract 2 from both sides. So we have y equals x minus 2. So here we now have two equations that are written in our y equals mx plus b form, so we can easily use a table or a graph for these. So let's get started. All right, so our first equation, y equals 2/3 x minus 1. When x equals 0, y equals negative 1. And we have a rise of 2, run 3. 1, 2, 3. So let's get that in there. And then we can draw our line, our graph. And our next one says when x is 0, y is negative 2. And we have a rise of a run of 1. It's an understood 1 over 1. So we'll just do this real quick. And go ahead and plot our line. There we go. And so we can see somewhere around 3, 1, the lines intersect. And so our ordered pair 3, 1 is going to be a solution for this equation. Okay, let's do it in a table now. When I say a table, it looks like this. And so let's just fill in some choices. Let's try 0, 1, 2, and 3. When I fill in with 0 here, I get negative 1. 1, let's see, that would be a negative 1/3. If I put in 2, that's going to be 1/3, positive 1/3, and 3 is going to give me a 1. And over here, let's do the same thing, 0, 1, 2, 3. When I plug in 0, I get negative 2. When I plug in 1, I get negative 1. When I plug in 2, I get 0, and 3, I get 1. So when we examine this, when x is 0, y is negative 1, on this equation, when x is 0, y is negative 2. Okay? On the next one, when x is 1, y is negative 1/3. And when x is 1, y is negative 1. These don't match up either. Okay, 2 and 1/3, 2 and 0, no. But notice when x is 3, y is 1. And that's exactly what we saw on our graph. Notice that this is our solution set, 3, 1. Okay, so let's move on. Okay, here's another example. Again, the very first thing we always want to do is solve for y. So we're going to say x minus y equals 2, solving for y, minus x on both sides, so negative y equals negative x plus 2. Let's divide both sides by negative 1. That gives us y equals x minus 2. Okay, so there's our first equation. And let's try the next one. It says 2y minus 3x equals -1. So let's add 3x to both sides because we're solving for y. So we have 2y equals 3x minus 1. Divide both sides, all sides, by 2. This is y equals 3 over 2x minus 1/2. Okay, so now we have two equations written in the y equals mx plus b form, which is our our slope-intercept form. So now we can graph a little easier, but this time I'm going to show you how to do it on your calculator. So let's go ahead and pull your calculator out if you want to put your computer on your video on pause for just a second so you can get your calculator handy. All right, so what we want to do here is, actually I'm going to clear that out. Let's try it again. Okay, so let's get your calculator on and let's get going. All right, so the first thing we're going to do to solve this using your calculators, you're going to turn on your calculator and go to y equals. And that's right up here, y equals, and you click on that and you have a whole list of y's that we can use. So our first one, we're going to just say x minus 2. So remember this little button up here that has all the alphabet letters on it. We're just going to choose the first one, which is x minus 2, and we're going to enter that. And then the next row, we're going to say 3 divided by 2x, go back to your x again, minus 1 divided by 2. Unfortunately, the TI-84 Plus knows how to the order of operations. Okay, so once we've got our two y's in, we're going to use this second and this button over here that says trace, but above it says calculate. So we're going to do that one. So we're going to say second calc, and we come up with the calculate menu, and we're going to go down to 5. Oh dear. Theoretically, we're going down to 5. Let's see if I can get my calculator back. Okay, so let's go to 5, and you can just, there we go. And you're going to see it graphing. All right, and the next thing we want to do is find the intersection of that. What exact number is that? All right, well, the first thing says first curve, and that's not really helpful, so just put enter. Second curve, that's not helpful for us right now. Guess is not helpful, but when we go to the last one, we see that the intersection is -3, -5. So they tell us that our intersection is -3, -5. So I'm going to go ahead and write that down. I'm going to lose my calculator once I do that, but we'll get going. So it says the solution is -3, -3, -5. All right, so we can just check to make sure that that's right. When x is, let's see, when y is -5 equals -3 minus 2. -3 minus 2 is -5 equals -5. So that is true. So that is truly a solution, that ordered pair -3, -5. Let's try the other one. Y again is -5 equals 3 over 2 times our x, which we said was -3 over 1, minus 1/2. That's -9 over 2 plus a -1 over 2 equals -10 over 2, which equals -5. And -5 does equal -5, so our calculator was right. The solution set for these two is -3, -5. All right. Why don't you try one on your own real quick? Put the video on pause and give it a try. You're going to solve each equation for y first. Okay, welcome back. I hope that when you solved each of your equations for y, you came up with y equals 1/2 x minus 3 and y equals 4x minus 3. So that was pretty easy. So now that we have it in the slope-intercept form, we can graph it. Again, when x is 0, y is negative 3. And this tells us our slope is rise 1, run 2. Rise 1, 2. All right, and so there's our point. So let's graph that. There that is. And then the next one says when x is 0, y is negative 3 also. But this time our slope is 4, 1. So we're going to rise 4, 1, 2, 3, 4, run 1. Run 1, 2, 3. Let's see, 1, 2, 3, 4, 1. There we go. And let's go ahead and graph that. There's our point. And so now notice that on the graph the line appears to intersect at the ordered pair 0, 3. So in this case our solution set would be 0, 3. We can also check it by using a graph or a table. So here's our table, and when you filled those in you should have come up with this set. And as we look at the two to find one that's the same, actually at the very beginning 0, negative 3 are the first ones that are the same, and you probably wouldn't really even have to do any more. So notice that when x equals 0, the y value for both equations is negative 3. All right, here's another one for you to try on your own. Put the video on pause for just a minute. And remember, when you do these, you have to do the graph and a table. All right, so use a graph and a table. Put the video on pause and then come back. Okay, welcome back. Here we go. If you solved it correctly, you should have gotten y equals 8 minus x and y equals 2x minus 4. So now that we have the equations in slope-intercept form, we can go ahead and graph them. When x is 0, y is 8. And we see that is a negative 1 over 1. So our graph is going to go like that. So let's go ahead and put our line in. And our second equation says when x is 0, y is negative 4. So let's go all the way down here, and we're going to go up 2 over 1. Up 2 over 1. There we go. And let's go ahead and graph that one. And now we can see where the lines intersect. The graph. On the graph, lines appear to intersect at the ordered pair 4, 4. So that tells us that our solution set is 4, 4. All right, let's see, did I lose something? No. Okay, so not only can we graph it to find the ordered pair, we can also make a table. And so you should have filled in some points on your table. And again, we compare our x's and y's on each graph, and eventually we get down here to the 4, 4, and we see that 4, 4 is a match for both of them. So 4, 4 is the solution to this system. Okay. So, systems of equations in example 2 have exactly one solution. However, linear systems may also have infinitely many or no solutions. So, a consistent system is a system of equations or inequalities that has at least one solution, and an inconsistent system will have no solution. So, let's talk about that in just a minute. So, we're going to be able to classify systems as consistent and inconsistent. We're also going to classify linear systems by comparing the slopes and y-intercepts of the equations, so they're going to be independent or dependent. An independent system has equations with different slopes. A dependent system has an equation with equal slopes and equal y-intercepts. Let's look at a chart of that. So it's a lot of words, so let's just look at a chart. So the first example that we see is a consistent and independent. All right, it's consistent because the graphs are intersecting lines with different slopes. So this slope is a negative, this one's a positive. They have exactly one point that's in common. All right, the next section it's consistent and dependent. And so what you're actually seeing, although you can't see it on here, and I don't have let's see if I can, well, anyway, there's another line right on top of this one that you can't see, but there's another line right there. All right, And it has exactly the same slope and exactly the same points. So we say that that is consistent and dependent. The graphs are coinciding lines. They have the same slope and the same y-intercept. The final graph picture is no solution. All right, there's no solution in common. These lines are parallel to each other. They have nothing in common. But remember, with parallel, they have the exact same slope, just no points in common. So this is inconsistent. The graphs are parallel lines. They have the same slope, but different y-intercepts. All right, so keeping that in mind, let's do a couple of example problems with that. The first thing is to classify the systems and determine the number of solutions. So obviously, the first thing we always want to do is solve each equation for y, and I think that we can all do that now, so I'm just going to actually, let's see. Let's just solve those real quick for each one for y. So x equals 2y plus 6. So we want to solve for y, so I'm going to write it 2y plus 6 equals x. And so subtract 6 from both sides. This means 2y equals x minus 6. Divide both sides by 2. We have y equals 1/2 x minus 3. So there's our first one. And our second one is going to be 3x minus 6y equals 18. Subtract our 3x from both sides. We have negative 6y equals negative 3x plus 18. Divide both sides by negative 6. Negative 6, negative 6. We end up with y equals 1/2 x plus negative 3. So when we look at these, we see that we have the exact same slope and the exact same y-intercept. Okay, so we can tell that this is the exact same line. Even though they look different over here, it's the exact same line. So what that tells us is that the equations have the same slope and y-intercept are graphed as the same line, and that's kind of hard to see. But that tells us that the system is consistent and dependent with infinitely many solutions. So you might want to go back and make a copy of that chart so you can remember that, what the differences are. Let's try another one. This one says classify the system and determine the number of solutions. So the first thing that we have to do is solve each equation for y. So let's say 4x plus y equals 1. Let's subtract 4 from x from both sides, minus 4x. So we have y equals negative 4x plus 1. And then the next one, so there's that one's finished. The next one's going to say y plus 1 equals negative 4x. Subtract 1 from both sides. So we end up with y equals negative 4x minus 1. So when we look at the two, we can see they have the same slope but different y-intercepts. So that tells us that we could just kind of see a little graph here. So the first one says to start at 1. And we're going to go down 4 over 1. And the next one says to start at negative 1 and do the same exact slope. So although my lines aren't very straight, you can see that there's no points in between here. These are parallel lines, and so there's not going to be any points in common. Okay, so the system is inconsistent and has no solution. All right, let's move on. This is our last problem, and it's a word problem. So it says, City Park Golf Course charges $20 to rent golf clubs plus $55 per hour for golf cart rental. Sea Vista Golf Course charges $35 to rent clubs plus $45 per hour to rent a cart. For what number of hours is the cost of renting clubs and a cart the same for each course? So the first thing we want to do is write an equation for the cost of renting clubs and a cart at each course. So let's let x represent the number of hours and y represent the total cost of dollars. So at the City Park Golf Course, we're going to say the total cost, Y, is going to cost us $55 per each hour, plus we also have to pay $20 to rent the golf clubs. All right, if we go to C Vista, our total cost is going to cost, let's see, $45 per hour. So it's only $45 per hour. However, we have to pay $35 for the golf cart, plus $35 for our golf cart. So now you can see that we have two equations that are ready, and they're already written in the slope-intercept form. So let's go ahead and see how long, how many hours we'd have to stay to get it to be the same at each course. All right, so we can first of all look and see that the slopes are different. We have a 55 and a 45, so that tells us that we have independent and it has exactly one solution. So there we've done our first part of this to determine what kind of system it is. And now we can use a table to solve this. So we're going to solve the system using a table of values. And since we're talking about hours, we're just going to do whole hours and half hours. So we're going to go by increments of 1/2. And I'm just going to go ahead and put the points in here for you. You'd have to on your own work, but for here I just went ahead and did it for us. So you can see we can start and compare. At golf course A, 0 hours is going to cost us $20, 0 is $35 here. For a half an hour, we see that we're going to pay different prices. For 1 hour, $75 and $80. For this is actually supposed to be 1.5 hours. 1.5 hours is $102.50. And 2 hours is $120 and $125. So where it's the exact same is when we rent for an hour and a half. So if you're going to go golfing for an hour and a half, you could choose either golf course and you're going to pay the exact same. And that's what we see right here. And that is the end of our lesson for today. Hooray! Celebration! So I hope you enjoyed this lesson, and I will see you in class tomorrow or soon. Hope you have a great day. Bye.